Hi guys, the last time I left you we had done this question, 2011 higher level question 5, and we had gone as far as the translation. So we had done the axial symmetry, the central symmetry and the translation, and I was to move on to the rotation in this lesson. Now, so just to get on top of that, and what is it that we require? It wants us to do a rotation clockwise through 90 degrees. And the rotation is between points P3 and P4. Now, we haven't done a rotation like this before. This is the new element today, and it can be a bit tricky, but we'll work through it and we'll figure it out. Okay, so the first thing I want to say, and this is where we get into the learning part of this, it has asked us to do a rotation from P3 to P4, and it must be clockwise to 90 degrees. So the first thing I need to break down in that statement, or the first thing that is important, and I know I have a line through this now, but that's because I'm using the same sheet as I had the other day, but what is the details I need to keep account of? So clockwise is important and 90 degrees is important, or at least very important. First of all, what do we mean when we say clockwise? Well, if that is a sketch of a clock, clockwise means to go in the direction the hands would go. Anti-clockwise is the opposite direction. So the right here is clockwise, and this side is anti. NTI as opposed to NTN or anti-Mary, anti-clockwise. Okay. Let me just zoom in a little bit now on what I'm at. Okay, now, so what that means then, and this is how I want you to apply this information every time. Look at the two levels or the two parts of information. So clockwise we're dealing with first. We'll worry about 90 degrees in a minute. Clockwise first. That means P3 is going to P4, but it must go in a clockwise direction, okay? Which means if I was drawing a little circle here, and I have it drawn there in doodle form, but the center of that little circle would be just within the curve here, which would be between P3 and P4. Now, if I apply that same knowledge down here, right? There's P3. You see it in the camera. Let me just move it in a little bit. There's P3. There's P4. There's only two ways I can come out of P3 to go to P4. I can either go in that direction, or I can curve in that direction. I can rotate. But only one of those arrows, those arcs, is correct. So if I go back up here and look at what I've written, even though it's a little bit messy up there, I'll tidy it up in a while. This guy is my anti-clockwise, my AC. This guy is my clockwise, my CL, right? So if this is my clockwise, that's what they've asked us to do. That means this arrow here is the relevant and important one. And the reality is I'm going to move every point in that direction, but in order to rotate it, I'm going to need a point somewhere over here. Question mark beside it because we don't know where just yet. But it's going to be at that side of my question. So P3 is getting rotated to P4 through a rotation point, and I don't know where. Okay, now, how do I figure out then, well, where the rotation point is? Well, then this is where we go to our second piece of information, 90 degrees. 90 degrees is, as we already know, it's a right angle, perpendicular angle. Okay, 90 degrees. So that means when I'm finished drawing this and I look back at the question, when I look at the lines that are created or that come out of the rotation point to 4 and the rotation point to 3, the angle in there is going to be 90 degrees. Now, our problem is, and it's back to this question mark, we don't know where that point is. But if I at least know that the angle is 90 degrees, I can say to myself, well, actually, it's going to be an isosceles triangle. If I joined, let's just join P3 to P4 for a minute there. Okay, just do it roughly. It doesn't have to be perfect. If I join that point, that triangle, that red triangle is isosceles because the length at this side would be the same as the length at that side because it's a rotation, it's a radius, R for radius, R for rotation. So if the lengths of the sides are equal, and my compass is going to go there, and I'm going to take P3 and I'm going to rotate it to P4, but I'm going to rotate it through an angle of 90 degrees. Can't I draw that triangle in my drawing? Bear in mind here at this stage, on our sheet, on our drawing, the only thing we have so far is P3 and P4. So rotation point, that's what I'm looking for. But let's look at this triangle. We all do maths. Angle in a triangle, total of 180 degrees. Okay, if I subtract the 90 degrees that is already present at the top, I am left with 90 degrees, and that 90 degrees is to be divided by 2 because it's divided over 2 angles. 45 is my angle. So my angle in there and my angle in there is 45 degrees. Now, that's only one way we can go about it. There's many more. But what you're probably thinking at the moment, you're looking at my sheet going, okay, yeah, but what do we do, right? So let's go on to the what do we do bit. So there's our question from the last day. I'm just going to zoom out a tiny bit. All right, so you remember that from last, I think, Friday. And my question so far, we went through an axial symmetry, central symmetry, and a translation. And there's my point P3, and point P3 is going to P4. So what I have to do now is that little sketch that I set up there, I have to draw it in here, but not in sketch form, in detailed form. Measurements, rulers, set squares, all the usual. All right, so let's get going on that. So how do I do it? I join P3 to P4. Why do I join P3 to P4? Because I want to get that line first. I can get that straight away. My problem is this one over here. So I join P3 to P4. So set square, pencil on the dot, slide the set square to meet. There's my line. Now I need to draw a 45 degree angle from each side, or there are other ways I could do it as well. I could also use the whole, the fact that 90 degrees is also the angle in a triangle when that triangle has as one side its diameter of a circle. So I could actually bisect here and draw a semicircle that would do the same job. I'm going to go with the 45 degrees method, even though it would ultimately be more inaccurate. But look, it'll be fine. And the reason why I'm sticking with that and why I'm not using the whole semicircle thing is your exam won't necessarily have a 90 degree angle. It could be 120, it could be any angle. So because this is 45, I'm going to do this. I'm going to do it with sliding set squares to be a little bit more accurate, to be honest. Now, so what does that mean? Will that work? No, that's a 90 degree. So I have to play around with my set squares to get it figured out. Oh yeah. So if I line, no, that's where I was. That would give me that way. No, I don't want that. What do I want? I want 45 degrees. Do you know, it would probably be easier to measure it on your protractor, but let's figure it out. Okay, so the first thing I'm going to do is, I've actually to do 2 stages of sliding set squares. So I'm going to take the one that isn't 45 degrees. There it is. And I'm just going to slide it away from the question slightly. So lining it up to P3, P4, slide it away slightly, and then come along with my 45 on top of that. So I go 45 degrees from that side. Now, I know it is difficult. There's a lot of lines here, but you just need to keep them clear in your mind. And 45 degrees from the other side. There it is. And where those 2 lines cross gives me my rotation point R. And that is my important point. And of course, before I continue on, I must check that that is in fact 90 degrees. Don't just assume, just like in maths, you do a question, you check that the answer is right. So there we go. There's the proof that that is a 90 degree angle. Okay, so now I have figured out that for the initial movement in this question, the initial rotation, the rotation point here, point R, very important one, is the one that would have contained the compass. So the compass will stay there the whole way through the rest of that question. And what happened originally, and let's just double check this, P3 moved to P4 through a 90-degree angle and at that rotation point. Clockwise as well. Sorry, clockwise is the bit I forgot there. So there's my symbol. So that's showing it. Now, here's the thing. To finish this off, and to be honest, the finish off isn't that terribly difficult, but I find kids at this stage, they get tired. You're after doing 40 minutes, maybe 35 minutes of a question already. Maybe it's not as accurate as you would have liked at the start and things are looking a bit funny and it can be hard to finish it. What I want you to do is I want you to work through each point individually and bring them across and literally work it through step by step. Each step on its own is relatively easy. And that basically means that it's okay if you keep your head about you. So I'm going to start with 0.5. And the reason I'm going to start up there at 0.5 is it's the one that's furthest away from everything. And I want it to be kind of fairly visible. So the first thing I'm going to do now to rotate every other point, I'm going to take the rotation point and join it to 0.5. So there's the first line. Now I'm changing the color of my pencil. I'm doing that on purpose. So this is purple. Keep that in mind. That's important. Now what's going to happen is I'm going to measure a 90-degree angle from that line from R to 5. Okay, because they told us to rotate each point through 90 degrees. So 90-degree angle, slide and set squares needs to go in again. So it's 90 degrees to the line R5. So there is my 90-degree line. Okay. The new 0.5 is somewhere on that. I don't know where yet. But I do know that it rotates about point R, or the rotation point. So my compass goes back into R and I open it up out to 0.5 and I rotate it until it stops at the other side of the angle. Now, here's where kids get confused. They say, but sure, that can't be right. Because the lengths between R and P3 and R and 5, well, sure, they're different. It looks funny, it looks wrong. But actually, what I want you to remember here is we're not transferring lengths. We are rotating. Everything is kind of held on point here at R and it's twisting. And every point, every number is moving through an angle of 90 degrees. Okay, so they all move the same amount in terms of the degree, so it's the same degree, but actually depending on where they are in relation to R, it will look like some of them move further than others. So now I did both of those in purple and the original lines I did them in green. I hope you can see the colors. I'll be putting up a picture of this anyway that you can print out as well and have it beside yourselves while you look at the video. I'll take a photograph of this and post it or I'll scan it. But now I'm going to go to another color, doesn't matter what the color is. Just again to highlight the next point. And I do think it is a really good idea to do this using separate colors so that you can clearly differentiate and move and see the difference. Because really what we're going to end up here at the end is it's like a rainbow of spokes, bicycle spokes, but they're all different lengths. So let's start with rotation point R to 4. Sorry, not start, continue on. So R goes to 4, so there's my line. Another different color. Back in again with slide and set squares. For the rest of this, by the way, I'm going to be doing the exact same thing over and over and over again. Okay, so set square up against the line. I go 90 degrees to that. So there's the second orange line. Now, the key here is that there's always going to be 90 degrees between the two orange lines. There's always going to be 90 degrees between the two purple lines. There's always going to be 90 degrees between the two green lines. That's why I want you to use different colors. It makes it easier. It doesn't necessarily make you more correct or more incorrect. So orange 0.4 twists and moves onto, and I just need to extend on my line a wee bit. There it is. And there is my new 0.4. So I have 4 and I have 5. And I need to keep working through all the rest. Going to go with a light blue for the next one. So I'm going to stop talking here for a while and I'm just going to finish it off. So R goes to 6. Actually, I won't stop talking. I'll keep talking through it. I was going to speed up the video at this point, but actually it's more important that you see it done over and over again and realise that that's literally what's happening. Nothing magic. R goes to 6. There's one side of my angle, finish my 90-degree angle. So now between the two blue lines, those light two blue lines is 90 degrees. So 90 degrees there to there, 90 degrees there to there, orange to orange, 90 degrees green to green, 90 degrees purple to purple. Okay, and then the last bit, once you've put in that 90 degrees, rotation point, compass goes in again. Can't get the compass into the same point. There it is. So there it is, 6. Bring it down. And each time you find a point or generate a point, number it, letter it, say what it is. So that's 0.6. So we have 5, 6, and 4. I'm going to continue on again. Going pink this time. So R to 3. Now, if you're thinking that this is as tedious, that this is terribly tedious and there must be some other way of doing it, no. This is as tedious as it is. It's all about working through it bit by bit. So radius to 0.3, slide and set squares, finish off the angle. I need to extend that out a wee bit. And again, compass. So the compass changes every time, which I suppose is different to some of the other symmetries. Which one was I doing there? Oh, 3. So, and this, by the way, is when it gets confusing, when you have this amount of lines. And it is the people that can deal with this kind of confusion. It's not difficulty, it's just a lot of stuff going on. It's the people that can deal with this are the people that will come out with the full marks. Not, as I said to you before, it's not always necessarily the best people at TG or the best people at woodwork or the best people at metal or whatever it is that get full marks. Oftentimes it's the people that are able to do an exam. All right, so that was 0.3. I need to do 0.2 now, and I'm going to do this one in yellow, even though I'm aware that on the camera that may not be terribly clear, but I'm running out of colours. So 2. Same thing though. R to 2. Here it is. 90 degrees to that. And you'll notice as well that we're beginning to get a pattern. The pattern is the colours are all reappearing. So everything there, look, purple, light blue, orange, yellow, pink and green. Purple, light blue, orange, yellow, pink and green. You're expecting a pattern. Now, in the exam, in terms of a question choice, it's not a fast question, right? You're not really going to be able to do this well within your 35, 40 minutes. It's not going to be fast. However, in my experience, if you pick this question, because generally there's no kind of, there's no weird kind of curveballs thrown into it. Nothing unusual generally happens in this question. So if you can afford the time, you can get full marks in this question. Whereas there's other questions that might be quick and might be fast, but one mistake in it and straight away you're down in the marks. So this is one, like when we did the actual rotation of solids question back, question 2, you know it well, the flag question. That's another one that's a long question in terms of how physically long it takes to draw. But in reality, it is a relatively doable question. Doable, there's a good word for it. Okay, I'm going to go in now with the light green because I am running out of colours. So that was 0.2. I've only left 0.1 and 0.7. So 1 is there. So rotation point to 1. Slide and set squares to get that nice 90-degree angle. Okay, and I mark it in. Now, whatever about the fact that this is kind of painful to draw, not painful, there's a lot, right? There's a lot going on, and there's a lot of lines going on. I actually love drawing it. I love nothing more than sitting here with my colours and rotating points and sort of getting a solution. There's something very satisfying about it. And hopefully you're getting the same thing as well, particularly at the moment where you might be stuck at a computer all day, just looking and listening, and then doing a lot of writing, or from what I can see, a lot of note taking. At least this feels like you're doing something. So sit down with it. I know I've given it to you to do anyway, and you should be sitting down with it and doing it, but do sit down with it and take time to actually think about it. Draw it tidy. Take your time drawing it. Draw it tidy, draw it well, draw it as accurate as you can. And remember, this is your first time doing a full rotation question at higher level. We've done transformation geometry a lot last year, you know that. But this is your first time doing a full rotation higher level version. So, and the only way to get used to something is practice. So, and it's quite satisfying. I'm quite fond of what I'm looking at now. I like the lines, I like the way it's laid out. I am quite proud of that work, as you should be. Okay, and when you draw tidy like that, when you take the time about it, now I know you won't have necessarily all this time at the exam, but when you do that, it is very satisfying, and at least you can feel, well, I did a good job there. And every line you drew, every curve you drew, every measurement you took, it was generating or getting you marks. All right, it's time to drying up. So 1 goes to 2. Now I'm hoping at this stage that, yeah, I know I'm expecting that accuracy mightn't be great, but that at least when I join all of this stuff up, that it should look like the original dog turned in a different direction. Was it a dog? It was. I can hardly remember at this stage. 3 to 4. 4 to 5. 5 to 6. It's quite handy actually to have to number them in order as they appear on the object, so that I can go 1, 2, 2, 3, 2, 3, 3, 4, you know, rather than mixing it up. 6 to 7. 7 to 1. Not quite there yet because I'm missing this collar bit, but because it's already on lines that I've already drawn, I will be able to finish this off pretty quickly by saying, right, this point, there it is on 7, 6. So I just rotate my point around. 7, 6. There it is there. And I also know that the collar is parallel to the base. I don't know, the neck. That line anyway, whatever you'd call it. There's the collar. There's my colors. Okay. And there is the question complete. And as I said already, do your best, do it tidy, do it accurate, do it well. Submit the question to me when you have it done. And over the next week, I'm going to give you a few of these to do. Now, when we do them, some days I'll be just giving you the rotation portion, which is like here today because I want you to practice it. But other days I will be giving you a full question, and bit by bit we'll get into a full exam paper. All right, guys, I hope that's okay. Any questions, send them to Google Classroom. Try your best at it. Use colours and just work your way through it. Actually, before I leave it, it's quite obvious there now how the colours are working. Look, purple, purple, blue, blue, pink, or whatever it is a pink. It's red, red, orange, orange, yellow, yellow, pink, pink, green, green, and then the lighter green. You can quite see it quite clearly there. So every point moves at that 90-degree angle. All right, guys, thank you very much. Bye-bye. Hi, guys, I just want to add something to the end of this video, and that is I have taken the marking scheme from your question, and on the marking scheme, of course, the question is drawn out. And I was just going to the bother here of highlighting it so I could attach it to your documents, but it dawned on me that there was a thing here that I could do that might help your understanding as well. And that is if I look at each point on the question. So over here, I have just highlighted the rotation. So there's my 90-degree angle in there in that corner. There's my rotation point R. Let me just zoom in. Point R. Oh, not the colour. There. Point R. Okay. But if I now just pick up a couple of other colours just to kind of highlight what actually is happening. So if I take, for example, the point from the rotation point R up here to, I suppose, the ear of the dog. If I complete that translation or transformation and I draw it in, so there's the original ear to the rotated ear, and if I look at the angle in there, it's 90 degrees, so that's the two purple lines. If I then do the same thing here from the angle R again, maybe to the, I don't know, the front of the dog, something like that, and look at it again at the complete rotation, so I can see again that the angle in there between the two pink edges is 90 degrees. And if I do one more just to show you what is going on, and again hopefully make all this understanding easy. So if I go there to the point that's just above P3, I don't know, was it 0.1 in our own one, I can't even remember, but if I highlight it again, there is the same rotation happening, blue to blue, 90 degrees, and that is how every point for the rest of that question continues on, point by point, bit by bit, until you end up with a fully finished question. So let's just take one last one. So or to here and or to the same point. So it's, I suppose it's how you use a marking scheme or a pre-done question in order to kind of figure out what happened. But what I'm trying to highlight over and over again, that in between the two same color lines, so yellow to yellow in this case, that there is a 90-degree angle, and that is how the rotation happens. Okay. What would be a good exercise to do would be to, if you could print this out, or at least, well, you'll be doing it in your own one, I hope anyway, but if you could print it out, to draw onto it just as I did there, would certainly help your understanding. All right, so I'll insert this into the video maybe at the end or in the middle, I'm not sure where, but it will help your understanding. All right, thanks guys again, bye-bye.